Hi everyone, good day and welcome to my class Maths with Victor. Kindly like, follow and share my Facebook page with all your friends and also subscribe to my YouTube channel so that you can enjoy my contents. Today, we want to talk about expansion of binomial expressions. So we have expand 2x minus 3y raised to the power 5. So we'll do this as quickly as possible. By expansion, we are multiplying this term with itself in 5 places because the power is 5. So this means 2x minus 3y multiplied by itself, 2x minus 3y, again 2x minus 3y, again 2x minus 3y, and finally 2x minus 3y. So this term will multiply itself in 5 places. 1, 2, 3, 4, 5. So what we have here now is that we are going to multiply this and this. And then the result will multiply to this. And then the result will multiply to this. And finally, the result will multiply to this. It is quite tedious. It is quite rigorous. But to go through all these processes will take a whole lot of time and energy. But there is a better way to do that, the Pascal triangle. So when we have binomial expansion to a high power, instead of multiplying out repeatedly, we can make use of the Pascal's triangle. So I will clean up this and apply Pascal's triangle to solve this problem. So what is Pascal triangle? Quickly, Pascal's triangle. Pascal's triangle gives us the coefficient of the expansion of binomial expressions. It gives the coefficient of the expansions and we can pick it up from there. So in Pascal's triangle, we have a triangle of numbers which represent the coefficients of different powers in expansion of binomial expressions. So we have 1. Pascal's triangle, it starts with 1. It always starts with 1 and ends in 1 in all degrees of powers. So we have 1 at the first level. At the second level, we have a triangle, forming a triangle, 1 and ends with 1. You can see the shape of a triangle. Then the next level, we are going to have 3. Here there is 1, here there is 2. We are going to have 3, but it must start with 1 and then end with 1. We need to find the number here. To get the number here, we simply add this and this. 1 plus 1, you have 2. That's the next level. The next level, we have 1. It always starts with 1 and always end with 1. So to get the numbers here and here, we add 1 and 2. You have 3, add 2 and 1, you have 3. But the next level starts with 1 also. Then 3 plus 1, 4. 3 plus 1, 4. Then 3 plus 3, 6. 3 plus 1, 4. And then ends with 1. Then the next level, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Ends with 1. And then the next level, 1. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And ends with 1. You can see how we build the Pascal's triangle. These numbers are the coefficients of the expansion depending on the powers. So the first one is that of the exponent of 0, the power of 0. The next one is the power of 1. The next one is the coefficient of the power of 2. The next is the coefficient of the power of 3. The next is the coefficient of the power of 4. And this is the coefficient of the power of 5, power of 6. We can continue building the triangle depending on what we are looking out for. But the problem we have is a power of 5. So we are dealing with the coefficients of the expansion for the power of 5. This is what we need for the power of 5. So the coefficient we need in this expansion is 1, 5, 10, 10, 5, and 1. So we can use this coefficient to solve this problem. So I'm going to clean up that and then solve this using this triangle. As easy as that, as fast as possible. So what we have is 1, 5, 10, 10, 5, and 1. So with these coefficients, we quickly expand. So what we have is you pick out the first coefficient, 1. That's the first coefficient. Then pick the first binomial term, the first term in the binomial expression, which is 2x. 2x. Raise it to the power, the highest power, 5. Then you pick the next expression, which is minus 3y, you raise it to the least power. The least power is 0. So you always start with the highest power for the first term, and then the least power for the second term. So we are done with this coefficient of 1. We move to the next coefficient, plus. Coefficient is 5. Then pick the first term, 2x. We started with power of 5 for 2x, so we start with the highest and go down to the least for the first term. For the second term, we start with the least power and move up to the highest power. So instead of power of 5, the power reduces to 4 for the first term. Then we have minus 3y. The power increased from 0 to 1. We are done with coefficient of 5. Plus, the next coefficient is 10. We pick the first expression, 2x. The power will further reduce from 4 to 3. Then we pick the next expression, the next term, minus 3y, and the power increases from 1 to 2. Plus, the next coefficient is 10. 10, and the first term is 2x. The power reduces from 3 to 2, and the next expression is minus 3y. The power increases from 2 to 3. And then the next coefficient, plus 5. The first term, 2x, where are we? From 2 to 1. Power reduced to 1. And the next expression, minus 3y, the power increased from 3 to 4. And then finally, the last coefficient, plus 1. The first term is 2x. The power reduces from 1 to 0. The next term is minus 3y. The power increases from 4 to 5. Take note of what we just did. We use the coefficients in the Pascal's triangle and then pick the terms and move the powers from the highest to the least for the first term. And then from the second term, we move the powers from the least to the highest. So for the first term, from top to bottom. From the second term, from bottom to top, in the voice of our president. Well, this is what we have. So we continue from here. So we can now simplify. So we have 1, 2x raised to the power 5. 2 raised to the power 5 is 32. 2 times 2 times 2 times 2 times 2, 32. So we have 32. X raised to the power 5 is x raised to the power 5. Then, in our laws of indices, 0 powers, anything raised to the power 0 is 1. So minus 3y raised to the power 0 is 1. So we're done with this. Plus 5, 2x raised to the power 4. 2 raised to the power 4 is 16. X raised to the power 4 is x raised to the power 4. And then minus 3y raised to the power 1 is minus 3y. And then we have plus 10. 2x raised to the power 3. 2 to the power of 3 is 8. And then x to the power of 3. Then minus 3y to the power of 2. Minus 3 to the power of 2 is 9. And then y squared. That's what we have. Then plus 10. 2x to the power of 2 is 4x squared. And then minus 3y to the power of 3. Minus 3 to the power of 3 is minus 27. And then y to the power of 3. Of course, whenever a negative number is raised to the power of an odd number, the number remains negative. But a negative number raised to the power of an even number, the number changes to positive. So we are there now. So we continue from here. Plus 5, 2x to the power of 1 is 2x. Then minus 3y to the power of 4. 3 raised to the power of 4 is 3 to the power of 4 is 81, I think. Yeah, 81. So we have 81y to the power of 4. Then plus, finally, 1. Any number raised to the power of 0 is 1. And then 3 to the power of 5 is 243. So minus odd power. So minus 243. And then y to the power of 5. So this is where we are now. So we can continue the expansion. So forgive me, I'm going to clean off here. So when I clean off here, I have 1 times 1 is 1, 32, and s raised to the power 5 is 32, s raised to the power 5. We're done with this. Plus 5 times 16. 5 times 16 is minus, is 80. 80 times 3 is 240, I think. Yeah, 240. So plus and minus, minus. So minus 240 x to the power of 4, and then y. Then plus 10 times 8, 80. 80 times 9, 720. 720 x raised to the power 3, y raised to the power 2. And then minus and plus will give me minus. 4 times 10 is 40. 40 times 27 will give me 1080 x to the power of 2, y to the power of 3. Plus 5 times 2 is 10. 10 times 81, 810. 810 x, and then y to the power of 4. And then minus 243 y to the power of 5. All right? So is there any like terms that we can add or subtract? No. So this becomes the answer of this expansion. So we can expand easily using the Pascal's triangle of coefficient of binomial expressions. Thank you. You can always share my video. Enjoy the rest of your day. Hi everyone. Welcome to my class Maths with Victor. Kindly follow, like, and share my Facebook page with all your friends, and also subscribe to my YouTube channel so you can enjoy my maths content. Today we have a problem on the board. We are asked to simplify 81 over 16 raised to the power minus 3 over 4 times bracket opens 25 over 9 all raised to the power minus 3 over 2 divided by 5 over 2 all raised to the power minus 3. Of course, this is actually very, very simple if we apply the laws of indices. So we begin from this expression. I want you to notice the powers here, and the powers here. They are all negative powers. They have minus, minus, minus. And in our previous class, we talked about negative powers of indices, that we can actually convert all negative powers to positive powers. We can change this minus to plus. But if we do that, we must reciprocate. We must turn this expression upside down. So if we do that, this becomes 16 over 81 instead of 81 over 16. The numerator becomes the denominator. The denominator becomes the numerator. So once we turn the expression upside, we reciprocate the expression. The power changes from minus to plus. We have 3 over 4. Then times, we can apply the principle here. So instead of 25 over 9, we have 9 over 25. The power changes from minus to plus 3 over 2 divided by applying the same principle. It changes to 2 over 5 and the power changes to plus 3. So we've simplified from here to here. So we can continue from here. So we look at this expression 16 and 81. 16 is the same as 2 raised to the power 4 all over 81 is the same as 3 raised to the power 4. So 16 is 2 raised to the power 4. 81 is 3 raised to the power 4. And I still have raised to the power 3 over 4. Times 9 is the same as 3 raised to the power 2. And 25 is the same as 5 raised to the power 2. And I still have raised to the power 3 over 2. Divided by 2 over 5 raised to the power 3. So we have simplified further. So we have raised to the power 4 here, raised to the power 4 here. It's a common power to both numerator and denominator. We have raised to the power 2, raised to the power 2. It's a common power to both numerator and denominator. So we can bring it out as 2 over 3 all raised to the power 4. This raised to the power 4 is this power and this power. It's for both numerator and denominator. So we can actually bring it outside the bracket. And then we still have times 3 over 4. In the laws of indices, when you have a power, another power, you can multiply the two powers together. Times, we have a common power here, so we can bring it out 3 over 5 all raised to the power 2. And we can multiply with the next power 3 over 2. Then divided by 2 over 5 raised to the power 3. So when we multiply this, 4, we cancel 4, and 2, we cancel 2. So we have 2 over 3 raised to power 3 left from this side. 2 over 3 raised to power 3 times a bracket, we have 3 over 5. We've cancelled 2 and 2, so raised to power 3 is left, raised to power 3, and then divided by 2 over 5 raised to power 3. So we can still simplify. What is 2 raised to power 3? 2 raised to power 3 is 8 over 3 raised to power 3 is 27, because the powers is for both numerator and denominator. Times, we have a bracket. 3 raised to power 3 is 27 over 5 raised to power 3 is 125. 5 times 5, 25. 25 times 5, 125. Divided by 2 raised to power 3 is 8 over 5 raised to power 3, 125. So we can simplify further. So we have 8 over 27 times, open a bracket, 27 over 125. In fractions, when we have division of fractions, we can change the division sign to multiplication, and then we reciprocate. We turn this upside down. So 25 comes up, and 8 comes down. So we have this. So what do we do next? This is 8 over 27 times 27 over 125 times 125 over 8. So 27 divide 27. 125 divide 125, 8 divide 8, and we're left with 1 as the final answer. It's actually very easy when we understand and apply the laws of indices. Thank you, and kindly. Hi everyone, good day and welcome to my class, Maths with Victor. Kindly follow, like, and share my Facebook page to all your friends, and also subscribe to my YouTube channel so that you can enjoy my content. Today, we want to simplify problems that involve powers by applying the laws of indices we have learned in the previous class. So we have 9 to the power of 3 over 4 times 27 to the power of 1 over 6 all over 81 to the power of 1 over 2. So I want you to notice the bases clearly, 9, 27, and 81. They can all be expressed as powers of 3. Because 9 is the same as 3 times 3. Of course, 3 times 3 gives you 9. In power form, this is written as 3 to the power of 2 because we have 2 3's. So 27 similarly is the same as 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And that is 3 raised to the power 3 in index form. And finally, 81 is the same as 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81, which is the same as 3 to the power of 4 in index form. What this means is that 9 can be a power of 3, can be expressed in such a way. 27 can also be expressed as a power of 3, and 81 can be expressed as a power of 3. So when that is known, we can simplify the basis. Instead of 9, I have 3 raised to the power 2. This is the same as 9. But I still have 3 over 4. 3 over 4 times 27 becomes 3 raised to the power 3, but I still have 1 over 6. All over 81 becomes 3 raised to the power 4, but I still have 1 over 2. So we've simplified the expression to have common bases. And in the laws of indices, we can multiply these powers out. When you have a power and another power, you multiply the powers. So if I do that, and I multiply 2 times 3 over 4, 2 we cancel 4, and you have 2 here, because 2 divided 4 gives you 2. And then 3 here will give me 1, 3 here gives me 2, and then 2 here, 1, 2 here gives me 2. So this expression simplifies to 3 raised to the power 3 over 2 times 3 raised to the power 1 over 2, all over 3 raised to the power 2. So this is what we have. And if you can recall the first law of indices, you have a base to a power, multiplies the same base to a power, we simply pick out the common base and add the powers. So when we do that, we have 3 raised to the power 3 over 2 plus 1 over 2. We simply pick the common base and add the powers. All over 3 raised to power 2. So when we add the powers at the numerator level, we have 3 over 2 plus 1 over 2. Of course, they have the same denominator, which is 2. So we add the numerators, 3 plus 1. 3 plus 1 is 4, divided by 2. 4 over 2 is 2. That means this gives me 2. So I have 3 raised to power 2 over 3 raised to power 2. An expression dividing the same expression. So this and this divides, and they give you 1 as the final answer. That means when we simplify this expression using the laws of indices, it gives the same result as 1. Of course, but from here, we can also apply or play around our knowledge of indices instead of dividing straight. In your second law of indices, remember, when you have a base to a power, dividing the same base to a power, simply pick the common base and subtract the powers. That's the second law, law of subtraction of powers. So when I do that, I have 3 raised to power 2 minus 2. And 2 minus 2 gives you 0. So this is 3 raised to power 0. And if you can recall the 0 law of indices, anything raised to power 0 gives you 1. So 3 raised to power 0 gives 1. So the same result. So 9 to the power of 3 over 4 times 27 to the power of 1 over 6, all over 81 to the power of 1 over 2 simplifies to 1 when we apply the laws of indices.